All right, we're going to finish up chapter 4 today, talking about polynomial and rational inequalities. What does that mean? What's a polynomial? Give me an example of a polynomial. Yeah. It's something like x squared plus 4x plus 3 equals 0. That's a polynomial function. Rational function is x plus 2 over x minus 3, a function over a function. But now we're going to look at inequalities. Earlier, we talked about inequalities on a number line. We learned about group notation or set notation, interval notation, and graphing. Now, since we're dealing with polynomials and rational functions, for example, we can have a function like this, which would be something x squared minus 2 is greater than 0. What we're going to be looking for now are interval answers. It's for example, for this one, I want to know where this function is positive, where it's above the x-axis. That's all we're doing is looking above and below the x-axis. So let's say this is at -2 and this is at +2. So the solution for this example would be from -infinity to -2, union 2 to +infinity. Right. As opposed to this example, what would be different?
Parentheses.
Very good. It would go from -infinity to -2 bracket 2 to infinity. Because here we can include the x-intercepts. So solving polynomial inequalities. Here are the steps. Find the x-intercepts of the function, or of the polynomial, I should say. Would you set it equal to 0, find the x-intercepts. Sketch the graph. And then determine what intervals satisfy the inequality. If we have the polynomial is greater than 0, we want what's above the x-axis. If it's asking for the polynomial is less than 0, we want what's below the x-axis. So it's important to set your polynomial equal to 0 to solve it. Let's look at example 1. Solve x squared minus 4x minus 5 is greater than 0. So we got a 0 on one side. That's good. Now what do we do? Factor. If possible, factor. If not, then use a quadratic formula. What are the signs going to be? Yeah, because the second sign's a minus. Be plus and minus. Very good. Very good. The bigger number gets what sign? The negative. So what times what is 5? When you subtract them, you get 4. 5 and 1. So the 5 goes there, the 1 goes there. So where are my x-intercepts? Yeah, -1 and +5. Those are my x-intercepts. Can I use those in my answer? No. Why? Because it's strictly greater than. Do I want the part of the graph above or below the x-axis? Yeah, I want this part above 0. So since it's +1, we know it opens up. So we're only interested in this part. So what's my solution? Very good. Because we only want the interval part of where the graph is above the x-axis. Pretty easy. As I said, is this stuff here is if you've been staying current, you'll have no problem with this. Example 2. Solve this polynomial. What's the first thing you got to do? It's set it equal to 0. So the first thing we got to do is move everything over to one side. Because the polynomial has to equal 0. So we subtract x and we subtract 3 from both sides. Three minus 1 is 2. 5 and 3 is 8. Then the second step, we factor. The signs are going to be right, and the bigger number gets the plus. What times what is 8 when you subtract and we get 2? Yeah, and the 4 goes in positive. 4 and 2. So my x-intercepts are at It's always the opposite what's inside there. Does it open up or down? It opens up. So at -4 and at 2. So we know it opens up. Do we want above or below the x-axis? Yeah, since it's less than, I want what's below. So I only want this interval. Can I use the endpoints? So it's -4 to 2 brackets. That's my answer. The hardest part students have is figuring out what does this really mean? I want to know where is the function below 0? 0 is the x-axis. Where is it negative? Example 3. Solve x cubed minus x greater than 0. So what's the first thing you got to do? It's already set to 0. How do you solve that? What do you factor? Yeah, they both have an x, so I can factor out the x, which will leave me with, remember, wherever you factor something out, divide to see what was inside there. Can we go any further? Is it? X squared minus 1 is the same thing as 1 squared. So it's x plus 1, x, it's a difference of 2 squares. You were right. So what are my x-intercepts? What's that? No.
1.
No. I want all of them. I want the complete answer.
Oh,
The x-intercepts. Give me the x-intercepts. How many do we have? How many solutions are we supposed to have?
3.
Did you give me 3 answers?
so it's negative.
Yes. Set anything that has an x, set it equal to 0. Because that x is there, 0 is a solution. So x equals 0, -1, and 1. What's the end behavior going to be? We have,
Down left.
very good. Since the A is positive and N is odd, it's going to go down to the left, up to the right. And since each of these multiplicities are 1, they're all going to cross. See, you start putting everything together what we learned. Now we have our graph. So what's our solution? What part of the graph do we want? What's above 0, right? So it's from where to where? Very good. We only want where the graph is above the x-axis since it's greater than 0. Excellent. And we can't use them because it's a strict inequality. There's no equal, less greater than equal to. Enough of that easy stuff. Let's do example 4 now. Which, if you thought it was easy, it's great because that means you've learned something. If you're still lost, that means you haven't done what you were supposed to have done. So how do we solve this one? What do we do first? Right, because it has to equal 0. So we have to have 0 on one side. So we move the negative 11 cubed minus 4 to both sides. Has to be equal to 0. Now what are you gonna do? Well, we could try grouping. That only works for cubic functions. Because if we did that, nothing factors here, 2 factors here, it won't give us anything. Good try though. Since you have 4 terms, you can try it. But no go. No. What's the next thing we can try? What did we learn in this chapter? How do we solve polynomials of higher order? We know we're going to have 1, 2, 3, 3 or 1 positive answers. We're going to have 1 negative. So by the Karch rule of signs, we have 1 sign change, 2, 3 sign changes, 3 or 1 positives. So it'll be positive to positive. No, positive to negative. That's 1. So I'm thinking we're going to have 3 positives and 1 negative answer. How do we do the rational zeros? What does Q represent? The constant, and P, so we have which is the top factor. That it could be 1, 2, or 4. The bottom is 1 or 3. One over 1, 2 over 1, 4 over 1, 1 over 3, 2 over 3, 4 over 3. These are all could be positive and negatives. So my possible solutions are 1, 2, 4, 1/3, 2/3, 4/3. So these are the ones I have to try. So what do you do next? Start doing synthetic division, right? And here's where I'm going to freeze it so you guys can do it yourselves. Because I don't know who's doing the work and who's not. I don't want you guys to pass the course and not know what you're doing. before y'all mess up. Here, how, we're gonna use one. What do we put inside this division thing? Here's x to the fourth, x to the third, x squared, x, and constant. Everything has to be allocated. 3, -11, 0, 10, -4. You have to make sure you put the 0 in place of x squared.
Also, you're, oh, yeah.
Yeah, so I don't want you guys to get dependent on just bobbleheading, because I want to save you all's
Yeah.
necks. Okay, out of the first, the integers, we know that -1, x equals -1. So, okay, here's the thing about it. Remember, how many negative answers will we have? We found the -1. So that should, all right, so now we're 1/3. 1/3 times 3 is 1. It's -13. Now, once we have fractions, it's not gonna happen. That's you. So it's gonna be 42 minus 13. (19/3). No. So negative 1/3 times 3 is -1, makes it -15. Negative and negative makes it positive. 15 divided by 3 is 5. No. Threes cancel, so it's a 2. -12. -12 divided by 3 is -4 times 2 is -8. 14 minus 8 is 6. 6 divided by 3 is 2. 2 times 2 is 4. So 2/3 is a solution. So all we have to do now is look at this quadratic equation. This is 3x squared minus 12x plus 6. We can factor out a 3. So far, our solutions, our factors are x equals -1, positive 2/3. And we gotta use the quadratic formula for this next one. A is 1, B is -4, C is 2. So positive 4, 16. -16 minus 8 over 2. 4 plus minus 2 radical 2 over 2. So our answers are 2 plus minus radical 2. So those are our 4 answers. You notice we said we're going to have 3 positive solutions. There we have. These are all positive, and 2/3 is positive. So we have an x-intercept at -1, 2/3, two plus radical 2. Radical 2 is a little bit over 1, so it's 3 point something. And so it's 2 minus 1 point something. So 2 minus 1 is 1, so let's say 1.5, yeah. It's a 4th order polynomial leading coefficient. That means the end behavior looks like this. Since all the multiplicities are 1, our graph looks something like this. So we have 3x to the 4th minus 11x cubed plus 10x. Minus 4. is less than or equal to 0. So do we want above or below the x-axis? We want below, since only want negative answers. So our answers are from -1 to 2/3. We can include the endpoints. Then we can include 2 minus radical 2 to 2 plus radical 2. Those are our solutions. Again, we have to use what we've discussed in this course so far. Now let's look at rational inequalities. Rational inequalities, you have a fraction over a fraction. It's either be above or below 0. You have to set it equal to 0, same as last time. Set equal to 0. Actually, if needed, simplify. Factor numerator. Factor denominator. Why do we have to factor the numerator? Find the x-intercepts. And we factor the denominator to find our vertical asymptotes. All of these points are important. Sketch the graph. All right, so example 5. Solve. 3x x plus 6 is less than 0. Actually, we also find the vertical and the horizontal asymptotes. So do we have a vertical asymptote? Where? Right, so the bottom equals 0, we have it at -6. Do we have a horizontal asymptote?
It's
Just only leading terms, just divide them. If they're equal, they cancel. It's just the coefficients. It's at 3. So here's our horizontal asymptote, here's our vertical asymptote. Now plot some points. Let's see where it's to the left of our vertical asymptote, -7. We got 3 times -7, -7 plus 6 is positive 21. So this part looks like this. Three times -5, -5 plus 6. So I'm sorry, -5, it's -15. At 0, it's 0. So our graph looks like this. So what are we looking for? Looking at where it's negative, where this equation is negative. It's negative, the graph is below the x-axis from where? What is the domain of the x below the x-axis? Here's an asymptote, it can't cross, so it's going from -6 all the way to 0. That's my solution. That's where the graph is below the x-axis. Example 6. So what's the first thing you have to do? Nope. Set it equals 0. So we have to subtract 1 from both sides. X plus 1, 2x plus 4 minus 1 is less than equal to 0. So we want where the graph is below the x-axis. We have to get common denominator, which is going to be 2x plus 4 over 2x plus 4. So we combine our equations, just worry about the top, x plus 1 minus 2x plus 4 over 2x plus 4. We don't need the first parenthesis. Distribute the negative sign to the other one. Negative x minus 3. All right, so our graph. Our 0, set that equal to 0, is at -3. So we have an x-intercept there. Set the bottom equals 0. We have x equals -2. That's a horizontal asymptote, or vertical asymptote, I mean. The horizontal asymptote is at -1/2. It's just the coefficients, since they're both the same degree. So if we plug in -1 inside the, because up here we know the graph's going to look like this. So at -1, so it's 1 minus 3, -2 plus 4 is -1. And the y-intercept is at -3/4. So what's our solution? What part of the graph are we looking for? Since it's negative, I want below the x-axis. So below the x-axis, here's the x-axis. So I want everything here. So it's from -infinity to -3. Unioned this whole graph from -2 to infinity. So yeah, you have to be careful. Is once you get everything set up as 0 on one side, I only want what's below the x-axis. It's from -infinity to this point, and then everything from this vertical asymptote on out. And the last one. Solve x minus 3 over x plus 4 is greater than equal to x plus 2 over x minus 5. First step. Does it matter which one you move over? No. So let's move this one over there. So we have an x minus 3, x plus 4, minus x plus 2, x minus 5. Greater than, equal to 0. Once we do that, what do we need next? Common denominators. This one needs an x minus 5. This one needs an x plus 4. Greater than, equal to 0. Leave the bottom factor. Don't multiply them together, because what do we have to do to find the vertical asymptote? Factor it, so it's there already. Now we got to multiply the numerators. So let's simplify the numerators. So we have to FOIL those out. We get x squared minus 8x plus 15 minus x squared plus 6x plus 8. A shortcut is x times x is x squared, 3x and 5x is 8x, 15. X squared is 4x, 2x is 6x, 8. I don't need the first parenthesis. I gotta distribute that negative sign to the second one. Simplify. X squares cancel. We have 14x. 15 minus 8 is 7. So my vertical asymptotes are where? -4 and +5. The horizontal asymptote is where? At y equals 0, because there are more x's on the bottom than the top. So it's x over x squared. As x goes to infinity, it goes to 0. What are my x-intercepts? Or my x-intercept? Set the top equal to 0. X equals 1/2. Set the top equals 0. So 14x equals 7. 7 divided by 14 is 1/2. What's my y-intercept? Set all the x's equal to 0. So you have 7 on top, +7 over -20. So it's -7 over 20. So let's use all that information. -4, +5. X-intercept is x equals 1/2. Y-intercept is -7 over 20. So the horizontal asymptote. Vertical asymptote. Asymptote. X-intercept is at 1/2. Y-intercept is at -7 over 20, which is just short of 3. How do we graph this picture now? We have two asymptotes, vertical asymptotes, and a horizontal. So let's pick a value on the left side of the left vertical asymptote at -5. We get negative makes it a positive. 5 times 14 plus 7, -1, -10. So it's going to be positive 67 over 10. So on the left, that'll be that graph. At 6, -14 times 6 plus 7. 10 times 1. Negative 91 over 10. Because at the end points, at the end quadrants, it's either gonna be above or below. Once we find a point, it's positive or negative. Since that's a horizontal asymptote, it's gonna be below it. Let's try negative 2 and 2. So negative 2. Negative 14 times positive 2. So it's 2, negative 7. 6, negative 3. 28 plus 7 over negative 14. It's going to be a negative number. 35, negative 35 over 14. Negative 2 and 7, or negative 2.5. At positive 2, negative 28 plus 7, negative 18. Negative 21 over 18. Negative and negatives makes it a positive. 1 and 1/6. Like something weird like that.
Yeah. Visual this.
So it's, as it gets closer to here, it's going down. As it's going here, it's going up. So what we're looking for is where it's way above the x-axis. So it's above the x-axis from negative infinity to negative 4. Negative 4 has to be a parenthesis because it's an asymptote. And then from our x-intercept to 5. So 1/2 to 5. It's bracket on the 1/2 since it's the x-intercept and parenthesis on the 5 since it's the vertical asymptote. That's the only part of the graph that's above the x-axis. Again, that's using everything we've discussed this semester so far. It's wrapping it all together. Right. That does that one.